Greetings, respected sir, ma'am. My name is Garrick Das. I'm currently pursuing BTech from Manipal Institute of Technology, and I'm currently in my third year in the branch of Electrical and Electronics Engineering. I'll be presenting my project report, which I have carried out through the ISTA internship under the guidance of Dr. S. Sarkar for the College of Aviation Technology, Dhaka. Um, so, as this was a remote internship, so um, the topic of the internship was design circuit diagram for split power engine using CAD. So this internship was basically for designing an eVTOL aircraft for split power engine. Um, so the motto of IST is work, experience, and discover. So I'll be talking about each of these topics, that is work, experience, and discover individually. So starting with work, this internship for starting with the what work I did, let's get to the basics. So the first thing is since we are working with electric aircraft, so what's the difference between electric and combustion aircrafts? So the moving parts. The electric aircrafts have less moving parts compared to the combustion because of the master cylinders and everything. So electric only just gives supply to the motor and the motor runs. So less moving parts. Cost of fuel. So the fuel prices. I mean, it's an fossil fuel, so the prices are also increasing and everything. So compared to electricity, it's comparatively cheaper. And then for noise, combustion aircrafts are a lot noisy compared to electrics. Electrics are very less noisy. Emissions also, a lot of carbon dioxide and everything are produced from the combustion aircrafts compared to the electric aircrafts. For coming to the range, electric do have a disadvantage at this point. Electric vehicles have a less range compared to combustion aircrafts, and that is why we are looking into a different aspect, that is the eVTOL aircraft. So we'll be discussing on that. So the electric motors used generally three-phase AC induction motors. The DC, we store the energy comes from the battery, that is a DC storage, and that is converted into a three-phase supply through rectifiers and three-phase controller. Right, we convert the AC to DC, DC to AC, and that AC to a three-phase system. And it might look sound very complex, but it's a simple design, cost effective, and very highly reliable. Right. So what are we working with? An eVTOL aircraft, the main purpose of our is transporting people for short distances. That is, there's a lot of congestion as we see in this streets, right? There's a lot of congestion and everything, a lot of traffic, and in fact, according to a lot of statistics and everything, we spend around 2-3 hours of our time in just in traffic. So to reduce that, this e-feature has come up, and they do is they provide aircraft from aircraft supply aircraft okay, from one place to another, which is not a very far distance, but they they try to make it as efficient as possible and as fast as possible. So how does battery affect the time of flight? So battery is a very important for an electric vehicles, and they are the main aspects as well. So lithium ion batteries are used, and of course batteries are recyclable, less carbon emission. I mean, batteries can be used for long day. I mean, they can be stressed a lot. They have a very high reliability and everything. But there is a disadvantage. The charging time, big. I mean, there's a lot of problem with the charging time and everything. But there are recent techs coming up. That is battery swap technologies. That is, I mean, it has come to the electric motorbikes. That is bikes, and they do is they swap the batteries instead of wasting a time in charging it. That is an approachable we could see in the fan, but increases weight. The main one of another main disadvantage is the increased weight. The battery will we have to find the sweet spot between the range we want and the weight the battery will have. That is, a battery we can't keep on increasing the number of batteries and hope that we'll have a greater range. It's not so. Um, Increasing the number of batteries will also increase the weight of the aircraft. It might reduce the range. So based on various calculations and everything, we need to find the right amount of battery we need to place. Also, we have to check for the distance the aircraft needs to travel and everything. Coming to different types of rotor design, there are multicopter, lift plus cruise, tilt rotor, and ducted vector thrust. In this project, I have worked with ducted vector thrust. Um, that is because the multicopter it has a very good hovering efficiency, but a very low cruise efficiency. Whereas this was the lift plus cruise was a improved version of the multicopter. So in multicopter we have smaller blades, and it definitely improves the cruising as well as the hovering efficiency, but those small blades produce a lot of noise. So then we have the tilt rotor. It does perform in all the aspects, but these rotors are very big, very large, and they need to be turned by an angle of 90 degrees from a completely vertical horizontal to a vertical for from hovering to cruise. So so the torque generated for these for turning these large rotors, there will be a high amount of machine is required, high amount of torque is required to turn these, and that would be an disadvantage, that is increasing the weight of the aircraft and everything. So finally we come to the ducted vector thrust. So here we have a smaller rotors, and there are particularly 36 rotors for the project I have been working on, and so these work similar to that of the tilt rotor, but I would require less torque to turn these from horizontal to vertical. So this is quite good. That's what we want. So the ducted vector are the Lilium Jet. This is a seven-seater model which was recently announced in April 2021. Even Europe has given support for to build airline operation for the system. It plans to make aircraft in partnership with custom cells, which will be providing the battery cells to this aircraft. The aircraft makers predict there are a lot of aircraft makers predicting that the launch of the eVTOL aircraft by 2024. So, mm, so this is a CAD model, and I'll take just explain the basics here. There are two battery packs, battery pack 1 and battery pack 2. We generally situated them in the front end there to balance out the weight, and we have parallelly connected the BMS module and the charging plug. This battery powers goes to the master controller, which gives supply to the various applications like the fan, the cabin lights, uh, my main switch, emergency lightings, and everything. The master controller also go the DC supply. It also goes to the DC to AC converter and then to my one single phase to three phase converter and then to my motors. So apart from this, it also has an auxiliary battery. This auxiliary battery is used in case for generally for main purposes for it to start the motor rotors and also for emergency purposes. That is for emergency lighting and everything. So this is the calculations for the battery capacity. Here are a few things like the weight of the aircraft. This was I searched through the Lilium web page and then got it. These are the some of the things. The number of fans are 36 fans, right? And for the battery energy, I had to assume as to be 5 kilowatt hour and battery mass as 400 kgs. So based on various formulas and also the calculations, we have found that the total battery. There are two things very important in this slide. That is the disk loading. That is 1636 Newton per meter square, and the battery energy required 62 kilowatt hour. So what do we mean by the disk loading is it's a ratio of amount of the weight of the aircraft to that of the area of the total area of the rotors. So it says how good it would help me in predicting how good that ratio disk loading has a it's actually there's a graph in the next slide which shows me the hovering efficiency with that of the disk loading. So the higher the disk loading, the lower the efficiency. It's inversely proportional. It can be seen through the graph. So the helicopter has the highest hovering efficiency because it has a very big, wing area and everything. So and based on our calculations, as discussed earlier, we got the hovering efficiency as 1636 Newton per meter square. So this was it for the remote internship. And coming to the second part, experience. I This was a nice experience as to seeing that we have a greater demand of electric vehicles, electric vehicle aircrafts, and to be honest, it was completely quite challenging. It was quite tough because it was I've never worked with with aircrafts and everything, so I had to go through a lot of papers and everything and get the basics cleared. Then, so it's actually quite interesting. It's really good to see that. I had not expected the electric aircraft to be progressing, and with this space, it's really interesting. Coming to the next part, that is the discover. It has really, I believe, this has really widened my scope as to, and I have learned a lot on the aircraft and everything. Also, under the guidance of my research advisor, Dr. S. He sent me a lot of papers and everything, and I guess it helped me build a lot and read. I had to read a lot and everything. It was a great experience, a wonderful experience. I would, um, I would really, I'd really love to work um, in these aircrafts and sometimes maybe get a hand-on experience. And that would be really interesting, really interesting. That's from my side, and thank you for this wonderful internship from IST Bangladesh. That's it. Thank you.